Use mathematical induction to prove that a given statement is true for all integers n is greater or equal than 1. The first step is, as usual, we consider the first possible value of n. In general, we can consider absolutely any value of n, but it's more useful to consider the first possible value of n. So we write for n is 1, the left hand side becomes sum for r from 1 to 1, so we just consider a term for which r is 1, and it becomes 1 over 1 plus 1 factorial. 2 factorial, it's 1 multiplied by 2, it's 2, so it's 1 over 2, and the right hand side becomes 1 minus 1 over 1 plus 1 factorial, which is 1 over 2, so we can see that as the left hand side is equal to the right hand side, true for n is 1. The next step is we consider, or actually we assume true for n equals k, and just rewrite a given statement substituting k for n. So it becomes sum for r from 1 to k, r over r plus 1 factorial is 1 minus 1 over k plus 1 factorial. And the next step is we consider or for n is k plus 1, it becomes, the left hand side becomes sum for r from 1 to k plus 1, r over r plus 1 factorial is equal to, we should do some transformations, simplifications, and our aim is to get finally that it is equal to the right hand side when n is k plus 1. So finally we should get 1 minus 1 over k plus 1 plus 1, k plus 2 factorial. So we should finally get this. And let's start. So the first step, it's actually also as usual, we can split it into two terms. The first term is the sum up to k, so it's sum for r from 1 up to k, r over r plus 1 factorial, and plus the last term corresponding to r is k plus 1, so it just becomes k plus 1 over k plus 1 plus 1 factorial. And then we can replace this by this, so it becomes 1 minus 1 over k plus 1 factorial plus k plus 1, k plus 2 factorial. And since we need 1 plus some fraction, we will not touch this one and just try to simplify these two fractions. And we can see that we can do a common denominator, but be aware because there is a minus here, so we can, since we need finally 1 minus, so we can do the next 1 minus, and it becomes 1 over k plus 1 factorial minus k plus 1 over k plus 2 factorial, and it becomes 1 minus, common denominator is k plus 2 factorial. What is k plus 2 factorial? It's k plus 1 factorial multiplied by k plus 2, so it becomes k plus 2, 1 multiplied by k plus 2 minus this, but also be aware because it becomes minus, and k plus 1 in parentheses, so it becomes minus k minus 1, and finally it's 1 minus k cancels 1 over k plus 2 factorial. It seems to be correct, and let's check, it becomes 1 minus, yes, it's correct. So it is equal to the right hand side when n is k plus 1. So it's true for n is k plus 1. And the general solution, conclusion as usual, if true for n is k, true for n is k plus 1. Since true for n is 1, true for any n is greater or equal than 1. And that's all for this question.